Okay, I'm going to quickly try to do a rational roots theorem and Descartes. But let's keep in mind what our end game is. Our end game is trying to find zeros. Alright? And what we know from this one, real fast review, is that because this is our leading term, 3x to the fourth, we know two things. First of all, because of this little 4 up top, we know the overall end shape is going to be a U. And because of this 3 right here is our leading coefficient, it is upward shaped. So we know that. Secondly, we know because of this 28 down here, we know we have a y-intercept of 28. So we already know a good bit of information about this just from looking at the function. Now let's go with the rational roots theorem. Our next job would be then to try to find where does this thing cross the x-axis, if any. So from that, we're going to say, okay, we got some possibilities, and we can use arbitrary numbers if we want to try to find where it might cross this x-axis. But the rational roots theorem, or the rational zeros theorem, narrows those possibilities down. The rational roots theorem says if you take the last term, the constant term, and put it over the leading coefficient. So 28 is our constant term, so we're going to take 28, and we're going to put it over 3. So if you take all the factors that give you 28, plus or minus 1, positive or negative 1, positive or negative 2, positive or negative 4, positive or negative 7, positive or negative 14, because 2 times 14, and positive or negative 28. Those are all the possibilities. And what it can give us 3, plus or minus 1, times plus or minus 3. Now what you're going to do is you're going to take each one of those top numbers and put it with that 1. And then you're going to take each one of those top numbers and put it with that 3 on the bottom. So our possibilities are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. See what I'm doing? I'm putting each of these top numbers with that 1. Plus or minus 7, plus or minus 14, plus or minus 28. Now then, you're going to do the exact same thing, only now you're going to put each one with a 3. So now my possibilities, I'm going to put the 1 with the 3. Plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 7/3, plus or minus 14/3, and plus or minus 28/3. So those are all of the possibilities. And you're going to get to try synthetic division with each one of those unless you can find some other way to narrow it. Okay? So let's see if we can. I'm going to go to a new screen because how many possibilities is that? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13 times 2 is 26. You've got 26 times to do synthetic division unless you can find another way to narrow it. So I'm going to go to a new screen. I'm going to recopy this thing. 3x to the 4th plus 4x cubed plus 2x plus 28. Nasty looking thing. Alright. Let's use Descartes' rule of signs. Let's remember what Descartes' rule says. Descartes' rule says that you have as many positive zeros as you have changes in sign for the original function. So we're going to go through here and count how many changes the sign has. There's 1. There's 2. I'm so sorry. I'm going to go back. Oh, I wish I could erase that one. No change. No change. No change. No changes in sign. No change of sign. No change. That means that of all of those 26 possibilities of zeros that we have from this screen right here, none of them will work. So you can eliminate all the positives. So now you've just wiped out half of them. All right, can we narrow it further? Let's see. Okay, now then, to find the negative possibilities, you're going to take everywhere that there is an odd exponent. Here and here. Odd exponents. Okay? What you're really doing is you're subbing in a negative x in all of these places. So see, it doesn't change this x to the fourth, because if you substitute a negative number in and then square it or fourth power it, it stays the same. Its sign doesn't change. So that becomes, that becomes then stays 3x to the fourth. This 4x cubed changes to a negative 4x cubed, then minus 2x plus 28. So what are the possibilities for negatives? There's a sign change, no sign change, and there's a sign change. So there's two changes of sign. So that means, according to Descartes, that there's either two negatives or no negatives. Right? And yeah, you're still going to have to try some numbers. But that means if I find one, I know I got to keep looking until I find the other. And there may be none. You may try it 13 times and you may never find any. But if you find one, there's for sure another. Because according to Descartes, there's either two or no negatives. Now with this being a 28 y-intercept up there, I'm wondering if there's what the possibilities are that there's no negative. So I might want to really think about graphing that before I plunge into those fractions of trying synthetic division with all those fractions. Anyway, I hope this helped.